Okay, let's look at a sample AP question. Pause the video, read it, see if you can answer it, and then come back for my explanation. So we have a function, f of x is equal to x squared. They tell us the derivative, in case we didn't know it, f prime of x is equal to 2x. Then they say a and b are constants. A is less than b. That may come into play. It may not. You never know. Find the value of c such that the slope of the line tangent to the graph at the point c squared. So slope of the line tangent to the graph, we should start thinking derivative, is parallel. Okay, we should be thinking same slope to the secant line, that's the line through 2 points, that joins these 2 points. So we need the same slope as the slope of the line joining these 2 points. So maybe we should start with calculating that slope. So b squared minus a squared over b minus a. All right, so let's factor because we can. Okay, that's b minus a times b plus a over b minus a. So that gives us a slope of b plus a. Now, we don't know what b and a are, but we know that that is the slope. All right, and that's the same slope as the slope of the line tangent to the graph. So tangent line, I should be thinking derivative of f. They gave it to me. So we want it at this specific point, f prime of c. F prime of x is 2x. So f prime of c must be 2 times c. Okay, and it's the same. They're parallel, so they have the same slope, so that we can set these equal to each other. 2c is equal to b plus a. They're wanting us to find an expression for c. So we divide by 2. And we get b plus a over 2, or b plus a is the same as a plus b. Okay, so pretty simple concepts, but they're putting them all together and they're giving you something without many values in it. So that's going to throw a lot of people off. This is definitely a question that they're expecting level 4s and level 5s to get on the AP exam. So it's supposed to be a challenge question. It's one of those that when you approach it on the AP exam, if you see this, there is absolutely nothing wrong with circling the number and automatically going on to the next problem and coming back to it, because it is a pretty tough question. I would not spend a lot of time trying to figure it out initially, because the questions are all jumbled up on the AP exam. Easy, medium, hard, they mix them all up. They don't do easy to hard. So you may miss a really easy question there at the end because you spent too much time on this question. And you may or may not have gotten the answer to this, but you definitely could have gotten the answer to the one at the end, but you didn't because you didn't get there, okay? So think about those kind of test-taking strategies. I know some of you don't like to skip around on a test, but I really, really, really suggest that you do on this one. Okay, so here's our next topic. We are going to look at derivative of trig functions, and we're also going to look at derivatives of the product of functions. So let's look at trig functions first. So let's recall those special trig limits. Okay, the limit as x approaches 0 of sine of x over x. Hopefully you still have that memorized. It's equal to 1. And then the limit as x approaches 0 of 1 minus cosine of x over x, and that one is equal to 0. We are going to use these to help us derive the derivative of sine. I'm going to show you where the derivative of sine comes from, and we need this to help us get there. Okay, so if we're trying to find the derivative of a function, remember we're going to start with sine. Okay, we're going to find the derivative of sine. So f of x is sine of x. Okay, so the derivative is equal to the limit as, let's use h's, okay? I prefer the h's over the delta x just because the delta x gets a little cluttered. The limit as h approaches 0 of f of x plus h, so we plug in x plus h into our function, minus f of x all over h. Now, if we plugged in 0 for h right here, we would get sine of x minus sine of x, which is 0 over 0. So we can't do that. We've got to manipulate this somehow. Well, what we're going to manipulate is we're going to use a trig identity that you may or may not have learned in pre-calc. I think that I briefly covered our sum identities in my pre-calc class, but I actually can't guarantee that because I think it's one of them that I kind of skipped over. But the good news is you really don't have to know or remember that for the AP exam. It's just kind of a neat thing if you do know it. So what the sum identity says, that if we're trying to split up the sine of x plus h, that is equal to the sine of x times the cosine of h plus the cosine of x times the sine of h. And of course we bring down the minus sine of x and the all over h. Okay, now let's see what we've got here. We have these two terms right here have the sine of x in common. Okay, so we are going to pair them together so that it's in a little bit more convenient of a form for us. So we've got cosine of x sine of h. We're just going to move that to the front. And then we've got minus sine of x plus sine of x cosine of x, or cosine of h. Okay, so all I did was rearrange those terms in the numerator, because what I'm getting ready to do is I'm getting ready to factor out the negative sine of x out of those two terms right there. Now, as I'm doing this, let me just point out, you are never going to have to recreate this from scratch. Okay, what I'm doing is factoring out the negative sine of x here. You are never going to have to recreate this from scratch, but I just want to show you why the derivative of sine is what it is. So I factored out the negative sine of h out over here, or negative sine of x, excuse me. Okay, now what I'm going to do is I'm going to decompose this. Fraction. Okay, so I'm going to split it up. The first part over the h, cosine of x, sine of h. Put that over h minus the sine of x, 1 minus the cosine of h over h. Okay, now the reason why I did that was because now look at what we've got here. That's our special limit. This is our special limit, okay? What was this limit equal to? That limit was equal to 1. This limit was equal to 0. So what we've got here, we've already evaluated the limit, so to speak, okay? So what we've got is cosine of x times 1 minus the sine of x times 0. Okay, just using those special trig limits. So the sine of x times 0 is 0. So the derivative of sine of x is cosine of x. Okay, so what we've got here is that the derivative d over dx of sine of x is equal to cosine of x. And I'm not going to go through the process of deriving the derivative of cosine, but it's a similar process. Its derivative is negative sine of x. Okay. So again, you will not have to derive these derivatives. Okay. You can, from this moment forward, just use the knowledge that we have attained here. And when you see the sine of x and you're asked what's the derivative of it, you automatically jump to cosine of x. When you see cosine of x and you're asked the derivative of it, it's automatically negative sine of x, okay? You do not have to recreate this process. I just wanted to show you where it came from. And for those of you that are nerds like me, that's pretty cool to do all that math and get that answer, okay? But again, you don't have to memorize that. All you have to memorize is what I have in the box. The derivative of sine is cosine. The derivative of cosine is negative sine. All you got to remember. So let's use that, okay? Find the derivative of each of these functions. The first one, y equals 2 sine of x. 2 is our constant multiple here. Okay, so dy over dx is equal to, you bring down the 2, the derivative of sine is cosine. That's it. Okay, example B, f of x is equal to the sine of x over 2. Let's rewrite that as 1/2 sine of x, okay? And so again, that's just a constant multiple. F prime of x is equal to, keep the 1/2, the derivative of sine is cosine. That's it. It's not rocket science here. We can apply our sum and difference formulas. Okay, y is equal to x plus cosine of x. So let me use the y prime notation. The derivative of x is still 1. The derivative of cosine is negative sine, so we write that as 1 minus sine of x. It is that straightforward. We can combine this with any of the rules that we've learned so far. So I want you to do that. I want you to practice on this textbook page with these numbers, and then come back for the product rule.